just like congruence has some patterns, shortcut patterns, to identify triangle congruence, the same is true with similarity. And it's the exact same patterns. So for congruence, we had SSS, SAS, ASA, and AAS. For similarity, we're looking at the exact same set of patterns. So we have three sides. Okay, so side, 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 similarity basically states that if you have three pair of sides that are proportional, then the triangles are similar. Okay, so if you had, and I'll just use kind of a simple example here, but if you had triangle ABC, DE, and F, and you were told that these sides are 5, 6, and 7, and this side is 10, 12, and 14. So on here, if you take a look at each of the pairs of sides, so we take our smallest side compared to the smallest side of our other triangle, has a ratio of 1 to 2. Is that true with every other side? 6 to 12 and 7 to 14. Are all of those the same ratios? Yeah, so based on SSS similarity, these two triangles could be identified as being similar. And so when you write it out, triangle ABC is similar to triangle, and then match the pieces. So A is opposite the side of 6, opposite the corresponding side is D. B is opposite the side of 7, opposite that corresponding side F. And C is opposite the 5, opposite that corresponding side is E. Okay, so you could make the statement that those triangles are similar by SSS similarity. Okay, SAS similarity, again mimicking the same type of pattern in congruence. If you have two pair of sides that are proportional and the included angle between them is equal, that's all you need in order to demonstrate two triangles are similar. So two pair of sides are proportional. And the included angle are equal, then the triangles must be similar. Okay, so if you had something like this, here's two triangles, given whatever the sides might be. So they may be some specific known value, they might be some unknown value. But if these sides are XX and YY, well, we have this vertical angle that's equal in both of those. And then we have a ratio of sides of X to Y and X to Y. So our ratio of sides is the same, which means it's proportional. And then the included angles are equal. So that's enough to show that this would be a set of similar triangles by SAS similarity. Right, the last one, the AA similarity incorporates both of the patterns from congruence, the ASA and the AAS. All you need is two angles. So if you have any two angles, angle similarity, any two angles between two triangles that are equal, the triangles are guaranteed to be similar. And often what you're going to see in something like this will be a triangle where you might have a set of parallel lines coming through. And if that was the case, you would know these corresponding angles are congruent to each other. This other pair of corresponding angles are congruent. And so by AA similarity, you know that these two triangles here would have the same ratios for their sides. Bless you. All right, so let's take a look really quickly at how you might approach these solving similar triangle problems.